Hi, we are currently studying about organic compounds. As scientists, we would want to be able to talk about a particular molecule and call it by name. That name would have to be a type that every scientist, wherever they are, would agree about which specific molecule we are talking about. So we would have to learn a set of rules in such a way that we will be able to name a molecule the same way. These rules are set by the International Union of Pure and Applied Chemistry, or IUPAC. Hence, we call them IUPAC rules. In this video, we will be learning about the functional groups and their nomenclature. In an organic molecule, a functional group is an atom or group of atoms that always reacts in a certain way. The addition of a functional group to a hydrocarbon structure always produces a substance with physical and chemical properties that differ from those of the parent hydrocarbon. The symbol R represents carbon chains or rings bonded to the functional group. By learning the properties associated with a given functional group, you can predict the properties of organic compounds for which you know the structure, even if you have never studied them. The functional group of an alcohol is an OH or hydroxyl group bonded to a tetrahedral carbon atom. The general formula is ROH. R represents the carbon chains or rings bonded to the functional group. The names of alcohols are based on alkane names. For example, CH4 is methane, and so CH3OH is methanol. When naming a simple alcohol based on an alkane carbon chain, the IUPAC rules call for naming the parent carbon chain or ring first and then changing the E at the end of the name to OL to indicate the presence of a hydroxyl group. In alcohols of 3 or more carbon atoms, the hydroxyl group can be at 2 or more positions. To indicate the position, a number is added. For this example, the parent chain consists of 4 carbon atoms, and the hydroxyl group is attached at carbon number 1. Hence, the name is 1-butanol. A 4-carbon alkane would be called butane, and so we take the E and replace it with OL. Hence, we call it butanol, and we indicate that the hydroxyl group is located at carbon number 1. Hence, the name would be 1-butanol. Here in this other example, we also have 4 carbon atoms in the parent chain. However, the hydroxyl group this time is attached to carbon number 2, and so the name would be 2-butanol. Please take note that in numbering the parent chain, we must number it in such a way that will give the lowest possible number to the hydroxyl group. For cyclic alcohols, the numbering begins at the carbon bearing the hydroxyl group. This carbon is automatically carbon number 1. A carbon chain can also have more than one hydroxyl group. To name these compounds, prefixes such as di, tri, and tetra are used before the OL to indicate the number of hydroxyl groups present. The full alkane name, including A and E, is used before the prefix. For this example, we have 3 carbons in the parent chain, so we call it propane. So the name would be 1,2,3-propane triol. This means that there are 3 hydroxyl groups attached to carbon number 1, 2, and 3. Let us proceed to more examples. For this particular example, let us find the parent chain, which is the longest continuous carbon chain, and count the number of carbon atoms. So here is the parent chain with 4 carbon atoms. Next, we have to number each carbon in the parent chain in a way that will give the lowest position number to the hydroxyl group. So we number it from the right. This is carbon number 1, where the hydroxyl group is attached, and this is carbon number 2, where a methyl group is attached. These are carbons 3 and 4. So the name of this molecule would be 2-methyl 1-butanol. It means that the parent chain is a butane with 4 carbon atoms and an OH group is attached to carbon number 1. The methyl substituent is attached at carbon number 2. For this next example, this is the parent chain with 5 carbon atoms. So the alkane name is pentane. At carbon number 2, a methyl group is attached. At carbon number 3, we have the hydroxyl group. And at carbon number 4, another methyl group is attached. So the name would be 2,4-dimethyl 3-pentanol. This means that the parent chain has 5 carbons, hence pentane, and the OH group is attached at carbon number 3. For the substituents, we have 2 methyl groups at carbon number 2 and carbon number 4. In this molecule, the parent chain consists of 3 carbon atoms, so it's a propane. The hydroxyl group is attached to carbon number 1. And on carbon number 2, we have 2 methyl groups attached to it. So the name would be 2,2-dimethyl 1-propanol. It means that the parent chain is a propane with the hydroxyl group attached at carbon number 1, and there are 2 methyl groups attached at carbon number 2. A hydroxyl group attached to a benzene ring is called phenol. Alcohols are classified as primary, secondary, and tertiary depending on the number of carbon groups bonded to the carbon bearing the OH group. For this alcohol, this is the carbon bearing the hydroxyl group, and only 1 carbon group is attached to it. Hence, it is a primary alcohol. For this molecule, this is the carbon bearing the hydroxyl group, and there are 2 carbon groups attached to it. Hence, this is a secondary alcohol. For this molecule, this is the carbon bearing the hydroxyl group, and 3 carbon groups are attached to it. Hence, it's a tertiary alcohol. The functional group of an ether is an atom of oxygen bonded to 2 carbon atoms. Ethers have a general formula of ROR'. R and R' represent carbon chains or rings bonded to the functional group. Although the IUPAC system can be used to name ethers, chemists almost invariably use common names for low molecular weight ethers. Common names are derived by listing the alkyl groups bonded to oxygen in alphabetical order and adding the word ether. For this molecule, there's an ethyl group on the left and a butyl group on the right. So the name is butyl ethyl ether. Again, we have to alphabetize, so butyl comes before ethyl. Similarly, we have 2 propyl groups on both sides, so the name would be dipropyl ether. Here, we have 2 cyclohexyl groups, hence we name it dicyclohexyl ether. Here, we have a methyl group on the left and a propyl group on the right, so the name would be methylpropyl ether. For branched ethers, it will be difficult to use the common names, so we have to make use of the IUPAC rules. The alkyl group attached to the oxygen is called the alkoxy group. For this example, since there are 2 carbon atoms, it's called ethoxy. Next, we have to number the parent chain. This is carbon 1, 2, and 3. We have the ethoxy group attached to carbon number 2 and a methyl group attached as a substituent. So the name would be 2-ethoxy 2-methylpropane. The common name for this is ethyl tert-butyl ether because this is ethyl on the right and this 4 carbon atom is actually tert-butyl. Similarly, for this molecule, we have to identify the parent chain and number it. 1, 2, 3, 4, 5. It's a pentane. On carbon number 3, we have the ethoxy group attached to it, and we also have a substituent attached at carbon number 2. So the name would be 3-ethoxy 2-methylpentane. This means that the parent chain is a pentane. At carbon number 2, there's a methyl group attached to it, and at carbon number 3, the ethoxy group is attached. A methoxy group attached to a benzene ring is called anisole. Carbon, hydrogen, and oxygen are the 3 most common elements in organic compounds. Because of the wide distribution of amines in the biological world, nitrogen is the 4th most common element of organic compounds. The most important chemical property of amines is their basicity. The general formula for an amine is RNH2, where R represents carbon chains or rings bonded to the functional group. For this molecule, it has 2 carbons, so it's called ethanamine. For this molecule, we have a cyclohexane, so the name would be cyclohexanamine. Here we have a 3-carbon parent chain, so from propane, this becomes propanamine. Since there are already 3 carbon atoms, we should indicate that the amino group is attached to carbon number 2. For this next example, we still have propane in the parent chain, but this time we have 2 amino groups. The amino groups are attached at carbon number 1 and 3, so the name would be 1,3-propane diamine. The parent chain is a propane, and there are 2 amino groups attached at carbon number 1 and 3. The parent chain has 4 carbon atoms, so it's called butane. 1, 2, 3, 4. The amino groups are attached to carbon number 1 twice and to carbon number 4 also twice. So the name would be 1144-butane tetraamine. For this molecule, there's a methyl group attached to the nitrogen and another ethyl group attached to it. So the name would be ethylmethylamine. Please remember to alphabetize the substituents, so E comes before M. An amino group attached to a benzene ring is called aniline. Amines are classified as primary, secondary, and tertiary, depending on the number of carbon groups attached to nitrogen. So here in methylamine, there's 1 methyl group attached to nitrogen, so it's a primary amine. Here in dimethylamine, there are 2 methyl groups attached to nitrogen, so it's a secondary amine. And here in trimethylamine, there are 3 methyl groups attached to nitrogen. Therefore, it is a tertiary amine. This time, we study the nomenclature of organic compounds containing the carbonyl group, or the C double bond O. The carbonyl group is present in all of these functional groups: aldehyde, ketone, carboxylic acid, ester, and amide. The functional group of an aldehyde is a carbonyl group bonded to a hydrogen atom. The general formula is RCHO, where R represents carbon chains or rings bonded to the functional group. We call this C double bond O a carbonyl group. This is the simplest aldehyde, called methanol, where the carbonyl group is bonded to 2 hydrogen atoms. In other aldehydes, it is bonded to 1 hydrogen atom and 1 carbon atom. To name an aldehyde, we change the suffix E of the parent alkane to Al, because the carbonyl group of an aldehyde can appear only at the end of a parent chain, and numbering must start with it as carbon 1. There is no need to use a number to locate the aldehyde group. So this one has 2 carbon atoms, so from ethane, it becomes ethanol. This carbon here is understood to be carbon 1. For this example, the parent chain has 1, 2, 3, 4 carbon atoms. So we call it a butanol. And there are 2 methyl groups attached to carbon number 3. So the name would be 3,3-dimethyl-butanol. This one's easy with a straight chain aldehyde containing 5 carbon atoms, so it is called pentanol. This aromatic aldehyde is called benzaldehyde. The functional group of a ketone is a carbonyl group bonded to two carbon atoms. The general formula is R C double bond O R prime, where R and R prime represent carbon chains or rings bonded to functional groups. In the IUPAC system, we name ketones by selecting as the parent alkane the longest chain that contains the carbonyl group, and then indicating the presence of this group by changing the E of the parent alkane to O and E. The parent chain is numbered from the direction that gives the smaller number to the carbonyl carbon. This molecule is called 2-propanone. 3 carbon atoms in the parent chain, so from propane it becomes propanone, and the carbonyl group is carbon number 2, so we have 2-propanone. Here we have a 4-carbon parent chain, so this is a butanone. We number it from the left to give this the lowest possible number, so 1, 2, 3, 4. So the name would be 2-butanone. For this example, this is the parent chain, and we start numbering from the left. 1, 2, 3, 4, 5. So it's a pentanone. This is carbon number 2, so 2-pentanone. For this molecule, we have 1, 2, 3, 4, 5 carbons in the parent chain. We number it from the left so that we will give the carbonyl group the lowest number possible. Notice that there is a methyl group attached to carbon number 3, so the name would be 3-methyl-2-pentanone. Here we have a cyclohexane, so this is called cyclohexanone. The carbonyl carbon is understood to be carbon number 1. The functional group of a carboxylic acid is a carbonyl group bonded to a hydroxyl group. The general formula is R C double bond O OH, where R represents carbon chains or rings bonded to the functional group. This is the simplest carboxylic acid, and it's called methanoic acid because it only has 1 carbon atom. So from methane, it becomes methanoic acid. We derive the IUPAC name of a carboxylic acid from the name of the longest carbon chain that contains the carboxyl group. We drop the final E from the name of the parent alkane and replace it by OIC space acid. Number the chain beginning with the carbon of the carboxyl group. Because the carboxyl carbon is understood to be carbon number 1, there is no need to give it a number. For this molecule, we have 2 carbon atoms. So from ethane, it becomes ethanoic acid. Here, we have 3 carbon atoms. So from propane, it becomes propanoic acid. Here, we have 4 carbon atoms. So from butane, this becomes butanoic acid. In this molecule, let us determine the parent chain and number it starting from the carboxyl carbon. 1, 2, 3, 4. So it's a butanoic acid, and on carbon number 2, there is a methyl group attached to it, so the name is 2-methyl-butanoic acid. This example is a bit tricky, so first we have to find the parent chain, which is the longest continuous carbon-carbon chain, which includes the carboxyl group. So this is 1, 2, 3, 4, 5. So we have a pentanoic acid, and on carbon number 2, we have an isopropyl group attached. So the name would be 2-isopropyl pentanoic acid. An aromatic carboxylic acid is called benzoic acid. The functional group of an ester is a carbonyl group bonded to an OR group. This is the general formula. Both IUPAC and common names of esters are derived from the names of the parent carboxylic acids. The alkyl group bonded to oxygen is named first, followed by the name of the acid with the suffix IC replaced by the suffix ATE. So for this example, let us name the alkyl group bonded to oxygen first. It's called a propyl group since it has 3 carbons. And the acid having 2 carbons is ethanoic acid. So we replace it with ethanoate. So the name would be propyl ethanoate. For this example, the alkyl group bonded to oxygen is methyl, and the acid has 6 carbon atoms in it, so it's a hexanoate. So the name is methyl hexanoate. Here, we have an ethyl group bonded to oxygen, and the acid has 4 carbon atoms, so it's a butanoic acid. We have ethyl butanoate. For this molecule, ethyl is bonded to oxygen, and for the acid, it's ethanoic acid, so it becomes ethanoate. So we have ethyl ethanoate. In this molecule, we have a methyl group attached to oxygen, and we have to number the parent chain because it has a substituent. This is carbon 1, 2, 3. So it's called methyl 2-methyl propanoate. Here we have an ethyl group attached to oxygen, and let us number the parent chain. 1, 2, 3, 4, 5, 6. There's a methyl group attached to carbon number 4. So it's a 4-methyl hexanoate. Ethyl 4-methyl hexanoate. This is ethyl, and this is the 4-methyl hexanoate. The functional group of an amide is a carbonyl group bonded to a nitrogen atom. This is the general formula. We name amides by dropping the suffix oic acid from the IUPAC name of the parent acid and replace it with amide. The ethanoic acid becomes ethanamide. The butanoic acid becomes butanamide. Pentanoic acid becomes pentanamide. This aromatic amide is called benzamide. If the nitrogen atom of the amide is bonded to an alkyl or aryl group, the group is named and its location on nitrogen is indicated by N. So looking at the parent chain, it's a propanamide, and we have a methyl group attached to nitrogen. So we name it as N-methyl propanamide. Here we have an ethyl group attached to nitrogen, and the parent compound is a butanamide, 4 carbons. So the name would be N-ethyl butanamide. Here we have 2 methyl groups attached to nitrogen, so it's called NN-dimethyl, and the parent has 3 carbon atoms, so it's called a propanamide. So the name would be NN-dimethyl propanamide.